Welcome back to the show. This is The Players. Now today tuko site and we want to find out what is the importance of reinforced steel when it comes to construction, whether it's for the beams or for the columns or for the slabs. So let's talk to Kevin, who is a contractor, and give us more insights on the importance of steel and the types of steel that we have. Karibu sana Kevin.
Thank you so much.
Hii kazi yako sio mbaya sana, naweza jaribu.
Naona umeng'ang'ana, umefunga vizuri sabi.
Yeah.
Yes.
Now please tell me, what is reinforced steel when it comes to construction?
It's typically reinforcements that is placed inside concrete in order to enhance the tensile strength of concrete. Yes.
Do we have types of reinforcement steel?
We have different types of reinforcement steel. We have twisted bars. We have mild steel. We also have stainless steel. But mostly in Kenya we used deformed bars.
Deformed bars?
Yes.
Why is that?
Originally, we were using twisted bars, but it did not have enough strength as the rib bars are.
What are some of the uses of reinforced steel when it comes to construction?
They are mostly used in slabs, beams, and columns. In beams, they distribute the load to the columns. In slab, the slab take the load from the slab. The reinforcements take the load from the slab to the beams, and then from the beams to the columns, and then from the columns to the foundation.
We'll get into a bit of practical use of the steel. Yes. But I want to know, are there different parts of the construction that use different types of the steel?
Firstly, I'll show you different types of rebars that we use in construction.
Okay.
I'll start with the D8, which is commonly used for the rings and for rings for the columns. This is that is D8, this is D10. We also have D12. These are all different diameters. If you measure the diameter for this one, it's different from the D12, from the D10, all the way to D32.
Okay.
We also have this one, that is the D16. It's a bigger one. We also have this one, this is D20. And we also have this one, which is D25.
Na hizi vitu si mchezo, ni mzito mzito.
Yes. So all these reinforcements are used for different purposes.
Okay.
For example, if you are building, you have a very big building and it has very big beams, you might end up using this D25 like we've used in these beams.
Okay.
For columns, you can use D20 and D16. It all depends with the structural design. Okay. So when you have a structural design, the structural design will guide you on what reinforcement to use where. Yeah. So if you go the Juakali way, what will happen? You'll use very big reinforcement, say this D25, for purposes which are not intended for this, because maybe the load of the house does not require D25. Yeah. So if you use structural engineers and go for a structural engineer, you might end up using a small reinforcement bar because the load capacity, the load of the house is not that big. Yes.
The bigger it gets, does it mean more expensive?
Yeah, it means more expensive. It also means it's taking bigger loads.
Okay.
Yes.
So now my question is, at times you find, because the big one is very expensive,
yes,
a fundi might want, let me give an example. So now this is what is required maybe by the engineer professional, the structural engineer. But because this feels expensive, I use the next in size, I try and use this. Yes. Can that work?
In construction, that will not work because it's going to be either expensive or it's going to be too cheap and then the building might collapse. So it's good to use a structural engineer because now you have these two. This is D16 and this is D25. You might, for the design, after the structural engineer has designed, he might be using this D12. Okay. Unaona? Okay. So, umetumia D16 instead of D12, it's going to be expensive for you. Also, if you go for a smaller rebar, the building might fail because maybe the load is too much. This is the beam that is going to carry the load for the slab. Okay. At this side, we are using hollow pot slab because the client wanted a bit of warmth in the house. Okay. And hollow blocks really help in that. Okay. For the slab, here we have ribs. These ribs are going to take the load from the slab all the way to the beam, and the beam will take the load to the columns. To the columns now? Yes. Okay. They are placed differently. When you are placing maybe the beam, you have to use a ring. But for a slab, in this case, we are doing hollow pots. We are just going to use BRC mesh on top of this. Okay. Yes. And for the traditional one, maybe you have a look at that. So this is the traditional way of doing
putting the slab.
There is this bottom one and bottom two, and you have top one and top two. For the bottom part, it's used to carry the tension, so the chini slab, and take it to the beams.
Okay.
Where we are seated, we were doing hollow pots.
The hollow pot, yeah.
Now for this hollow pot, for this solid slab, it's going to be reinforced both ways, chini na juu. These reinforcements distribute the load. I'ma take the load. Like when I stand here and it's already covered in concrete, my load will be taken by the slab to the beam.
To the beam.
And then from the beams to the column.
Okay.
Yes.
All right. And now the column itself, how do you reinforce, or how do you use the steel?
We first check the structural engineer's design.
Okay.
And the structural engineer design guides us in what reinforcements to use.
If I already have a design for the house and the structure, what are the ways I can save on steel?
To save on steel, what you'll do, you'll have to look for a structural engineer who will design the house. If you feel that it's still too costly, what you can do value engineering. Value engineering will help you determine the actual the actual load that is going to be distributed to maybe the columns and the foundation, and the value engineering designer or the engineer will give you a detail that is using maybe small reinforcements as compared to just using without knowing the load and not knowing the load capacity of the columns.
A lot of people are obsessed with shortcuts, and I don't know why, and you find that's where maybe buildings are collapsing. What are some of the big mistakes people make when it comes to reinforcement steel?
When it comes to reinforcement steel, I think mostly people go for the cheap rebars. There are reinforcements which do not meet the standards but are there in the market.
Okay.
That is one mistake of quality of the steel. The other mistake is placing the reinforcement rebar and not following the structural design. Also, there is something we call maybe overlaps. They are not doing overlaps the way they are supposed to be done.
Yeah.
And also going for local fundis to guide them instead of using professionals. So if you use professionals, it's going to be cheaper on your side, because maybe the building may not fail, and also you might not use a lot of money in the project.
So mtu akitaka advice ama expert opinion, akupate wapi?
Unaweza nipata social media as Kevin Muchai Kamau or Kevin Kamau Muchai. And also you can call me on 0712 29 96 21. I
hope you've learned the importance of using experts. A lot of times we fail when it comes to construction because we want shortcuts. I'll take a short break. I'll be right back on the show.